The method of undetermined coefficients for second order ODEs. How to make initial guess for the right hand side. This is non-homogeneous term. When we are solving, let's say y double prime something here plus by prime plus cy equals some function here, not zero, some let's say g. If this is either a polynomial or exponential or just sine cosine or their combinations, then we can make an initial guess in this way and solve for the particular solution, If this right hand side is a second degree polynomial like this, at squared plus bt plus c, where a, b, c are constants, they could be zero, we might have just t squared. If we have a second degree polynomial in the right hand side, then our initial guess should be just general second degree polynomial, so the constants will be different. If we just, and then there are examples below, okay, I'll show you in a moment. If you have an exponential function a times e raised to alpha t, this a should be different a. It could be 1, but we don't know, we start with generic a. If we have like say a sine or b cosine or a sine plus b cosine, in either case we always write a linear combination of sine and cosine. Even if we just have sine, we have to write both, because when we find the derivative of sine we get cosine, so it's always a cosine plus b sine. Another, when we have a second degree polynomial times e alpha t, it will be general second degree polynomial e alpha t. In this example, it was just a constant e alpha t, generic constant a, let me say unknown to be determined, e alpha t, but when we have second degree, it will be generic second degree. And if we have a linear combination of sine cosine e alpha, look at this a and b, we have to have generic a and b, otherwise same thing, we just have to, so it might be like 3 5 or 0 2, we have to write both a and b unknowns. In the same way, if we have degree 2 polynomial cosine k plus degree 2 polynomial sine, it will be generic degree 2 cosine plus generic degree 2 sine. So let's look at particular examples. If the right hand side has -3 or any number, and when we make the initial guess, that will be just a, and we try to find the value of a, we find the value of a. So it's a 0 degree polynomial, just a constant. Here 5t or 7t, it is in fact first degree polynomial, we write generic first degree polynomial at plus b. Here is t square, in fact t square is degree 2 polynomial, it's got only t square, but we have to write generic degree 2 polynomial. We can have t square plus 3t, this will be the same, okay, or t square plus 3t minus 7, this will be the same, because this is a degree 2 polynomial, we have to write generic degree 2 polynomial. We have like only sine or only cosine, it will be a linear combination of those two, okay, a sine plus b cosine, or a and b doesn't matter, these are unknown constants anyway. If we have exponential function, just exponential function, you have to write a times exponential function, because the constant is 1, but we don't know, so just a. And here got more, we can have, let's say here, I want to make it bigger, okay. So suppose we have degree 1, t means degree 1, t e to the negative 2t, that e to the negative 2t stays the same, t means that's the degree 1, so we have to write degree 1 generic polynomial. And look at this, t square cosine t squared is degree 2. So generic degree 2 in both places. Because of cosine, we have to write cosine and sine. So it works in this way. And if we have, let's say, et times cosine, here we got degree 2 cosine, so generic degree 2 cosine. Here exponential cosine. Due to this exponential, we have aet or this et in both places. And for cosine, a cosine, b sine. Or we can write this in this way. We could have written because of et is e3t is same thing, and here is cosine, so we write a cosine plus cosine t plus b sine t. This is in expanded form. We could have factor e3t out. Okay, in the same way, if we have, let's say, cosine t plus, so we got two terms in the right hand side, cosine plus exponential, so we have to write for cosine a cosine b sine, plus for exponential we just write constant times exponential. Okay, and here is t degree 1 polynomial times sine t, generic degree 1 sine plus another generic degree 1 polynomial cosine. Because of sine, we have to write sine and cosine, and these are generic degree 1 polynomials. So we got 1, 2, 3, 4 constants, in fact, unknowns. And if we have plus means two terms, t squared, that's degree 2. So generic degree 2, that is one part. Okay, in fact, this is just one part coming from the first term, and t sine t is like that. So sine t means we have to have sine and cosine. T means degree 1, so degree 1, degree 1. Okay, final.